I'm going to talk about basic batch and Slurm, and I am going to first give a very quick introduction to what a batch job is, and then show some of the important commands, and then a job script and a little bit about that. So I am going to move forward. So in this workshop, if you are a member of one of the course projects, then these are the project IDs you will be using both interactively and in your job scripts. And I will show you where to put them. There is also storage space on each of these clusters that you can use. And I can go ahead and switch to the one that's on tetralit. So I will go here. And that's apparently not where it's supposed to be, which is odd. Let's do this. Let's see if I have made a mistake. It should have said courses fall 2025 instead of courses fall courses, because I was tired clearly when I fixed that. So I will fix that, and it should say 2025 here, just like it does for this one here. And the same thing here. It should also say 2025 here. This is me who put a wrong argument into my script when I fixed it. So courses fall 2025, or you can also put it in your home directory. It's not going to use that much space. Might be good to have it here. On tetralit, there is the directory users, and under that, tetralit has created a user for those who have a user account there. So I am going to go into mine. This, and I have stuff there. And I'm also going to fetch the table here. Then untable it. And you all did that earlier. I did it in my home directory when I went here. So let us here where I am on Dardel. To copy this part here. And then 2025. And here I have a directory. And I'm also going to fetch the table to that directory. And untable it. Okay, so you should now have a directory exercises with capital E. Under that, there is day 2. So let's go into that. And then to the cluster that this is NSC's cluster. 3 files there, 3 batch scripts to play it. And here I go to PDC, and you can see there is too many because I went into the wrong day. You see it like this. So, good. Now I am prepared here to show you. There are also some reservations, but they are only on Max, HPC2, and LUNARC. So let's scroll past those. But if you are at one of those centers, you can use the reservations there. I don't know what the status is for the reservation at UPPMAX, other than I think Björn talked about getting one. So what is a batch job? Batch systems, they keep track of the system resources and take care of the scheduling of the job of the many users that are submitting to the batch system. And it puts them in a queue. And it also enforces some system resource usage and job scheduling policies. And most of the Swedish HPC clusters are running Slurm. Slurm is an open source job scheduler, and it handles 3 key functions. So it allocates exclusive or non-exclusive access to resources for some period of time. So it knows what resources are there, how many CPUs, GPUs, how much memory, and such things. And it has a framework for starting, executing, and monitoring the work on these allocated nodes, that is the cluster. And it also manages a queue of these pending jobs so that they are allowed to start according to what policies are at that center. And since the policies vary a bit, I'm not going to talk about that, but they are usually listed at the center. But it is mainly about when a job is allowed to start. So Slurm can handle thousands of nodes in a single cluster, and it can handle up to 120,000 jobs per hour. So much more than there is on any of the centers. So what is a cluster? Well, there is a bit more information in the common section about understanding clusters, which if you want to read it, but this is just a brief overview. So a cluster is the whole compute system. It has login nodes that you log into when you log into the system. And then there is some compute or calculation nodes where the calculations happen. And it's a network of computers where each computer works as what is called a node. And a node is basically a computer. And it has processors, of course, RAM, sometimes GPUs. It has sometimes local disk and such, and that is called Scratch. And then it's connected with various interconnects, often InfiniBand or Signal. So this would be how we look at it. So this is one node, and then other nodes, and also connections to the storage and the login nodes and the internet itself. So, and you log in to a login node with internet, and through either SSH client of some kind or a thin link or one of the desktop on demands or some other system. And on the login node, you can make some file management, and you can also do light data analysis, but nothing more than that, because the login nodes are shared with a lot of users. And if you use up all the resources on the login node so it becomes slow, it means it's slow for everyone. So if you start a huge job on the login node, someone may notice and kill it on the admins, because it makes it unworkable for everyone. So don't run huge things on the login nodes. Run it on the computation nodes, calculation nodes. They are what are supposed to be used. And any longer resource-intensive or parallel jobs must be run through a batch script or an interactive session. And if you're using the desktop on demand systems, that is also interactive sessions, and that is a batch allocation. So if you run it there, it's also okay. There is a link to a guide to what a cluster is here that I wrote some years ago. And there is newer information in this NAISS course about running jobs on HPC systems that we had this week. So what are some important commands for batch jobs? Well, there is submitting the job. That is, of course, important. You do that with sbatch and the job script. The job script, you can name it as you want. It's custom to have a suffix that is .sh or .sbatch or something, but it's not necessary. You don't need to put anything there. It's just whatever makes it easy for you to find in your directory, even when you have many files. And now I'm going to go ahead and see if I can submit one of the files I have here. So I'm going to open it and see if there's something I need to adjust. And indeed there are. Because this the thing is, all the programs that I'm running, they are located in a specific directory, and then there's also a directory for each of the systems. And so I'm setting the path to the program directory here. And that means I need to change this one word here. Since I fetched the tarball and put it in the expected place, that is the only thing I need to change. Everything else is set, and I'm going to talk more about that in a moment. Right now, I'm going to use it to show you what happens when I submit this job. As you can see here, you get a job ID, this one here. And that is how you recognize this job. It is identified with this job ID. And you can get a list of your jobs with SQ minus U and your username, or SQ minus minus me. If I just say SQ, I'm getting everyone's jobs, as you can see. And it's a lot, so you don't want that. And here I can see that my job already ran. It produced the default named output, which is slurm minus job ID.out. I am going to go ahead and submit this job a few times, because then I can see how it looks here with SQ minus me. And you can see they are all pending. And in a little while, they will go to running here. So this is the job IDs. It's running on TetraEdit. This is the name of the job, which is the batch script's name, unless you give a name for the job, which you can do inside of the job script. The user, the state, which is right now pending. It could be R for running, and it could be CG for completing, and a number of other states. But as you can see, they have now run. This is the time it has run, because it hadn't run yet. And this is how many nodes, or rather its cores, it's that you have allocated. And you can see here, it created an output file for each of these runs here. I could also give the Slurm command on the command line instead of in a batch script. I would then say srun and then list all these commands that otherwise are inside of the batch script. The advantage to putting it in a batch script is mainly that you, of course, can use the terminal. You could anyway by sending it to the background, but the good thing about it is that you can easily see later what it was that you did in this batch script. Otherwise, you would have to write it down if you just wrote all of it on the command line. But now you have it in a batch script, and you can easily see what you wanted to change or something. So aside from using the SQ minus me, you can also do scontrol show job and the job ID, and then you get a lot more information. Let's try and submit this again a few times. And then if I say scontrol show job, and then I will copy one of the job IDs, like that. And then I get a lot of output here. I see I have the job ID and the job name and who ran it. It's me. Which account did I run in? The project ID and the state. It's currently completed, so it ran during the time here while I typed. And you can see when you submitted it. And here you can see when it started, how long it ran in time, and how long it was allowed to run is here from this, and so on. And which partition it ran in, what node did it run on, how many cores did you have, CPUs, and so on, including the work directory you submitted it from, and where the job script was located. So you can find many things here, and it's very useful if you want to see why it did not run, for instance, if there was something wrong with the node, or also to see when it might perhaps start. So, assuming you have now sent away your job, or maybe several of them, and you notice that you actually made a mistake, so you don't want it to run and use up allocation. So instead of doing that, then you say S-cancel and then the job ID, because that simply removes the job from the queue. If you say S-cancel minus U and your username, you will remove all your jobs. And again, this was how to submit jobs, and you can get info on which nodes and partitions are there with S-info. And you can see here, it is some nodes are draining, some are allocated, some are idle. And we can do the same thing here at PDC and see which kind of partitions they have. PDC is big into partitions, and you need to list them in your job scripts in order for it to run. You can see there is GPU partition, main partition, shared partition, and so on, long. There is also a number of private partitions that belongs to companies or groups. The other ones can be used. So let us go on here. There's some guide and documentation here further that you can find. And let's look at the workflow. So you write a batch script, and inside it, you load modules you need. I'm going to open this batch script here with Nano. So I have sorry. First, you have the project ID. You always need that. And here, this is the project ID. And that is what was listed in the beginning of this file. You can also find it with the command project ID, project info, sorry. And that will list the projects you are in, and you can use those here. First, this line here is called shebang or something, and that is sort of an incantation. It's telling it to run in the bash shell, and that is the only shell that is compatible with the batch system, so just put it there and don't worry about that. Then we come the project ID, and then we come the time, and the time is hours, minutes, and seconds. So in this case, it's 10 minutes, way more than is necessary, but and you could lower it. The lower time you ask for, the more likely there will be a small space in between other jobs that are waiting that your job can run in. But if you ask for too little time, the job will end before it has finished running, and you don't want that. So ask for a bit more than you think is needed. And it differs what is the maximum amount of time you may run. It's usually about a week, 10 days, something like that, depending on the system. Then you are asking for one core. In reality, this is asking for one task, but since default is one task per core, you're asking for one core. This was serial script, so that is fine. Here I set the path. You wouldn't always do that if it was in the same directory. Then I'm saying which modules I need. And here I need some Python module and some prerequisites for it. And I'm also loading the SciPy bundle to get to NumPy, things like this. And then I run my Python script, which is located in this directory. So that is what I would do. And this is a simple serial script. And other types of scripts, we will look at those in the next days. And this is just a description of where you find these scripts, and we talked about that already. So you will be able to find those. And here you can see examples of this script at different places. And here that is without the path set, because this is in case you just copy it from the screen. Here is the small program that's running. And here you see it needs a numpy, and numpy is inside by the control, as either Björn or Michelle have told you about. And now I wanted you to do a quick exercise. There's not a lot of time left. There's maybe 5 minutes if we are gracious. But see if you can do this. Otherwise, the solution is here and is also in the directory. But this first serial example script, this one here that you found further up on the page. Yeah, this one here for the different centers. Change that so that it instead runs this code instead of the MMM matrix multiplication code. And the trick here is to, of course, it has arguments that it needs to, you need to give those in the batch script. And there are solutions for it here, how we do it. But try and make the change yourself and simply try and submit the scripts and see that they run. If you're using them directly, remember to change the path so it fits with you. For me, it was just changing the username. Yeah. And if you don't know any of the editors, which I'm assuming you do now, on Linux, then Nano is the simplest one to use. You cannot use it on Dardel because it's not installed. There you will have to use Vim or something. But otherwise you can use Nano. And you exit it and you also save it with holding Control down and pushing X on Nano. And I'm going to stop here. And then after lunch, I'm going